Good day, viewers. You're welcome to my YouTube channel, Maths with Adevic. I'm Victor Adewale Adeleke. If you are yet to subscribe to my YouTube channel, do well to subscribe, like, and share. It is very important so that whenever I post materials like this, you will always get notified. Okay, it's yet again another class on geometry laws. As I promised, I proposed that I will be teaching geometry laws. A lot of students, like I said earlier, that has been storming my DM asking for laws to be proved under geometry. So I promised that from ends, I would start providing solutions to many of their formulas, how it came about. Because I told you, if you do not understand the beginning of a problem, you may not be able to solve the problem. So how are we going to get over geometry as a problem in mathematics? It's just all about understanding the laws that governs it and how they came about, how they were formulated. Okay, now this is trigonometry. Like I said the other day, what is trig? Tri stands for three. Then the gono is a Greek word also, which stands for angle. Three angles. It's saying something like three angle. Then what is the metric? The metric is talking about measurement. The metric is talking about what? Measurement. So how are we going to bring about the solution to all of this? How did this all started? Now, Pythagoras is the person that is really standing as the father for trigonometry. Not all geometry per se, but when you talk about trigonometry, you cannot talk about trigonometry without mentioning Pythagoras. Pythagoras made a lot of theorems. We have among such that ones we know very well, the Pythagoras theorem, which said the square of the opposite plus the square of the adjacent equals the square of the hypotenuse, which we denoted to be a square plus b square equals c square. Okay, now let's see how we're going to bring about the trigonometric identities. When you are going up to advance into tertiary institution, you're going to find trigonometrical identities. So let's see, how did this law come about? I will make another video for proof of the trigonometrical, Pythagoras theorem. I will make a special video on that. So because we want to use the Pythagoras theorem now to solve something here. Now we already know that Pythagoras theorem says a square plus b square equals c square, which I already said is the opposite. This is the opposite squared plus the adjacent squared equals the hypotenuse squared. You can also rewrite to say b square plus a square equals c square. What matters is that the two of them must be summed up together. Both the opposite and the adjacent sides must be squared and summed up together to give the square of the hypotenuse. So before we move ahead, there's another thing again that we want to talk about. So okay, over h, then your tan over a. Now you can see this is representing the trigonometrical functions sine, cosine, and tan. So let's see what we are going to come about from this. So we already know that sine theta. So from here we should note that sine theta equals what? I think I should write this down. Sine theta equals opposite over what? Over hypotenuse. Cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. Now we also have the inverse trigonometrical functions. We have the inverse trigonometrical functions. If you're talking about sine theta, the inverse of sine theta is the cosec theta. So it's going to be equal to, now if you watch this properly, now this is, what is the opposite? The opposite is what? Is a. This is the opposite. The hypotenuse is what? Is c. For cos theta, the adjacent is b and the hypotenuse remains c. Then for tan theta, the opposite is a and the adjacent is b. So how do we know that this is the hypotenuse, this is the adjacent, and this is the opposite? How do we know that? Okay, a very quick one. The angle theta is always in between the hypotenuse. So whenever you see an angle theta in every right angle triangle, it's always in between the hypotenuse and the adjacent. And how can we notice the hypotenuse, sorry? Whenever you look into a right angle triangle, it's always made up of one place is always at right angle, which is perpendicular to the what, to the base. So this is at right angle. This point here, this line here, sorry, is at right angle to this other line. So you can see the angle 90. So this angle 90, the sharp edge of this angle 90 is always facing the hypotenuse. So this is a very quick one so that we know. So whenever you see any right angle triangle, you may be able to spot out every right angle triangle specifically with an angle theta. You'll be able to spot out the hypotenuse, the adjacent. So the other place that is always opposite the hypotenuse is known as the opposite. Then this other part is known as the adjacent. That's a quick one for that. If you don't still understand, drop it on the comment section. I may create a special video to explain that. So let's move on with that. So cosec theta is equals to the reverse, which is the inverse. So it's going to be the reverse of A over C, which is C over A. Then for cos theta, that's the inverse of cos theta is sec theta. So it's going to be the inverse, which is what becomes C over B. Then the last one, which is cot, C-O-T, cotangent theta. So I think I should write that here. Cot theta is equals to what? It's going to be the inverse of what? Of this. So become B over A. So now let's see how we can, from this formula now, bring out something smart. From Pythagoras, a square plus b square equals c square. So the first thing we need to note is just divide all through. This is a very quick one, a very smart way to derive your trigonometric identities. So just divide all through. Remember what the golden rule of mathematics was: whatever happens to the right hand side happens to the left hand side. So when we divide all through this by c squared, so we can rewrite this to become a over c. Then you have this plus b over c. C squared divided by c squared is going to give you 1, because whatsoever number divided by itself remains or becomes 1. So we have 1 there. So what is a divided by c? A divided by c is what? Is sine theta. So you can put it there, sine squared theta, plus b divided by c is what? Cos. So we have cos squared theta must give you what? 1. This is the first rule. This is the first rule proven. This is the first rule proven for trigonometrical what? Identities. Once you have noted that, go back to your Pythagoras theorem. A square plus b square equals c square. So what do we do here now? Divide all through by a square. So here we have 1. Then what do we have here? Plus b divided by a all squared equals to c divided by a all squared. What is b divided by a? B divided by a is what? We have cot. So we have that 1 plus what? Plus your cot squared theta must equals what? What is c divided by a? C divided by a is cosec theta. So we have what? Must be equals to cosec square theta. This is another law proved. Then the last law that I want to talk about, a square, still the same, a square plus b square equals c square. Then what do we do now? The only person we've not really divided all through it is what? Is b. So we are going to say divide all through by b square. So what happens here? Here becomes 1 plus what? A square divided by b square. Let's just play a very fast one there. Now a square, what is a divided by b? A divided by b is tan. So we have, it becomes tan square theta equals, what is c divided by b? C divided by b is sec square theta. This is the other law proved. So that is just how simple trigonometric identities are. I think these are the 3 most important trigonometric identities that you need to know in heart. You don't need to cram them, just understand how they came about. I may try to create another video that will find questions under JAMB syllabus that would solve all these problems out and see how they can be used mathematically. If you are yet to subscribe to my YouTube channel, do well to subscribe, like and share. It is very important so that whenever I post materials like this, you always get notified. Stay tuned.